well, first I wanted to look at the determinants of matrices. So matrices are, it's just another way of writing a system of equations, right? A way of organizing it?
The purpose of matrices has more to do with solving really complex, lots of equations, lots of variables. In other words, if you had 11 equations and 11 variables, that would be extremely difficult to solve the way we're used to solving it. But with matrices, it would be fairly straightforward to solve. Matrices are also used in a lot of computer graphics, anytime they have to reflect stuff. So there's various uses for matrices. But so the only thing I would suggest at the moment is you try to memorize everything they give you. In other words, if they are talking about a 2x2 matrix,
2x2.
2x2 would be something like this. Not necessarily 4 different numbers, but that's a 2x2. There are 2 rows and 2 columns.
Yes, sir.
Okay. Another way, if I want to write that more generally, I'll write it this way. And the determinant equals A times D minus B times C. So what would the determinant of that 2x2 matrix be?
That would be 6 plus 4, so that would be 10.
Good. And that's how you do it. Now, it gets a bit more complicated when you have 3x3 matrices. Quite a bit more complicated. So unless you specifically have some problems that are greater than 2x2 matrices, then we probably don't need to get into the more complex stuff.
I have some 3x3s.
Okay. What specifically are they asking you for the determinant of a 3x3?
We're looking for the determinant.
Okay.
All right.
Hold on, let me give you a clever way to figure out the determinant. There's a 3x3, and incidentally, the first number is the number of rows, and it matters. When you go to multiply matrices, you can multiply a 3x2 by a 2x4, but you can't multiply a 3x2 by a 1x4. The middle number the number of rows have to match the number of columns for you to be able to multiply matrices together.
Yes, sir. And
furthermore, the associative property doesn't hold. In other words, matrix A times matrix B is not the same as matrix B times matrix A.
Yes, sir.
Okay. So, what's the determinant of that 3x3 going to be?
So that is going to be, you multiply A times E times I, and, right? First?
I think so. I'm going to have to look. I'm not going to give you 100% until I look it up, but I think I can remember it.
Okay. And then B times F times G.
What was the next one?
Or I think you are adding plus B times F times G.
Okay. I see what you're doing, and that was the clever little trick I was going to teach you, where you go ahead and you write the A, B, C, and the B, E, H, and then it's always just a string of threes. So you're going that plus that plus that minus that minus that minus that, I believe. Does that sound right to you?
Would the fourth column, or the first one that you added, would that be A, D, G?
You know let me look it up, because I'm not certain, and it definitely matters. Matrices 552. Matrices are definitely a difficult subject.
Because I think that's what they explained us to do.
Yeah, this little trick is where you rewrite rows or columns A and B.
Yes, sir.
Okay, so here I have it. Hold on a second. Let me see if I was correct here. One second. So here's an example. Let's deal with an example, and then we can figure out. I'm not sure I can figure out in my book what the exact formula is, but I can certainly, they've got an example of what the determinant is of this particular matrix.
Okay.
Let me go ahead and write it. It's 3 by 3.
3 by 3.
Okay, let's just see if I was right. Okay, so AEI is what?
AEI would be -1.
Okay. And what did I say next? I said BFC?
Yes, sir.
I think that's what or H. No, hold on. See, AEI plus BFC. And what is BFC here? It's 2, 3. In other words, let me do this. It'll make it easier. Let me rewrite those first two columns.
So it would be BFG. Is that right?
Yeah, you're right. It would be BFG. Yeah, I was miswrote that. Okay, so what is BFG? That is minus
-6. -6.
Okay. And then the next one is CBH.
0.
And the first three are all added, and the last three are all subtracted.
Yes, sir.
And the last three go the other direction. So what is
Yes, sir.
CEH? GEC again was, oh, we didn't do that, but we can do it now. What is that?
GEC, that is going to be -1.
Okay. Now let's just keep everything in the parentheses. The next one is HFA.
0.
Plus I, what did I do here? This is A, B, oh, that's a D.
ID.
That's a D. So let's go back. Does that affect anything? Not yet. No, it might affect something on the first round. In other words, it wasn't CBH, it was CDH. What was CDH? 0, right?
Yes.
I'm becoming more convinced that this is the correct way to do it. This determinant is -10.
Yes, sir. -10.
Now, whether we get it or not, I don't know. But I'm absolutely convinced now that you take, let me use a different color. You take that, you add it to that, and you add it to that, and then you subtract that, along with that, along with that. That's
yes, sir.
And it works really nice if you rewrite the two columns.
Yes, sir.
Now, I don't know. Do we need to prove that that's correct here? Do I need to start again and let's figure out what the determinant is?
I think it might have been okay for this example since B and D were both 2.
Ah, okay. Ah, good look. Yeah, so I got away with my error. Boy, that's rare in math. That's really rare. Wow. So, yeah, no, I'm, if you have another problem, we can do it, and then we'll verify that this is the proper way to do it.
Okay.
If you
I have one.
Notice that this works for a 2x2 also. In other words, if I have a 2x2, what am I going to do? I'm going to multiply that, and I'm going to subtract that. So
Yes,
the ones with the negative slope are what you're multiplying together all the time. The ones with the positive slope is what's being subtracted. In other words, it's AD minus BC for a 2x2. That being
yes,
A, that being B, that being C, that being D. And
yes,
it's basically the same principle when you go to a 3x3. You start out with the negative slope, only got 3 of them, and then you subtract from that the positive slopes, and you got 3 of them.
Yes, sir.
Okay?
And when you said the negative and positive slopes, that's just
Of those lines. That's a negative slope line.
And that was just you.
I could have said goes from upper left to lower right.
Okay.
Because
So
you have to figure out, on a 3x3, do you start with that one or do you start with this one?
yes, sir.
And you start with the negative slope one.
That's right.
Same with a 2x2. In other words, if you can remember the definition for 2x2, then you can pretty much always figure out how to do a 3x3. You
Yes,
just
sir.
have to start out, that's the negative slope, I'm subtracting the positive slope.
And it's the same principle for any square matrix.
Yes, including a 4x4, you would basically do the same thing. I would imagine you would have to draw 3 columns instead of 2 additional columns.
Probably.
In other words, these are only to make it easy. Those two additional columns that I added.
Yes, sir.
In general, you're going to be doing these on a calculator anyway. You're
On a calculator.
doing these by hand, except on a math test on matrices where the teacher says, okay, do this by hand, no calculator.
Okay.
Okay? And they might give you a 3x3 and say, what's the determinant? I would be surprised if they didn't, given the fact that they have already given you that in your homework.
Yes, sir.
All right, what else do you got?
Okay. Kramer's rule to solve a system of equations using matrices. So Kramer's rule basically, I want to make sure I understand this properly, and then we can do a problem. Let's just keep it simple and have two variables in this system. Let's use an example, okay? 3x minus 2y is equal to 8. Five x plus 7y is equal to 3.
All right.
Okay.
Basically, what they do, again, I'm going to have to, I was looking in my book for Kramer's rule, but it boils down to those coefficients.
The coefficients.
All
right.
Notice that my matrix is all the coefficients. I do want to find Kramer's rule specifically. Oh, wow. I'm not sure this book's going to give it to me. I don't think it is. No. Hold on. I do have another book that should have it. Just a second. I may look it up in the index. Oh my goodness, they don't have it either. Why? It's Kramer with a K, isn't it?
With a C.
Oh,
I have it with a C.
Now, hold on. This book should have it. Yeah, they do. 778. Gives you a clue of how advanced it is. It's on page 778.
Wow.
All right. Kramer's rule. Here we go. So, if you have an equation, ax plus by, which is the format that our equations are in.
Yes, sir.
And they use s. I'll use s also. I don't know why they use s, but, oh, I see why, because this is a c.
Okay.
Equals t. So they use s and t for their numbers.
All right.
And if I want to solve that system of equations, x is equal to the determinant of st bd, and I'll give you a little clue as to how to memorize this, divided by the determinant of the left side, which is a, b, c, d. And the y value is equal to the determinant, and it's going to start off a and c, and then s and t, divided by the determinant of the left side, which is your A, B, C, D. Okay?
That's right. Okay.
That's easy enough to apply. The question is, how do you memorize it? First of all, let me erase everything I wrote over there. That, I don't know how that ended up so off base, but notice the numerator of the x.
Numerator of the x.
Starts out with the st in the first column, and then follows with the coefficients of the y variable, the b and the d in the second column.
Okay.
Now, before we go to the denominator, let's go over and look at the y variable. Its numerator starts out with the coefficients of the x variable, a and c, and then goes to the coefficient or the constants, s and t. Both of them are divided by the same thing, the same matrix, which represents the coefficients on the left side of the equation.
Yes, sir.
So, let's figure out what x is. Let's do it piece by piece. Fill it all in, and then we'll figure out those determinants. So what goes in the first cell in the numerator on the upper left?
8.
What goes below that?
3.
What goes next?
That is going to be -2.
And
7.
goes in the bottom matrix.
3. -2, 5, and 7. And when you're calling out the coefficients for a matrix, are you going across the rows or down the columns?
You can do it either way.
Okay.
When you're using Kramer's rule, I kind of like to do columns.
Okay.
Because we were looking for those two coefficients.
Yes, sir.
So I did columns. I don't think it matters. Sometimes you can do rows. But now let's figure out the determinant. In other words, what's the determinant of that numerator?
I think that's going to be 62.
What's the determinant of the denominator?
It's going to be 31.
So the x value equals what?
2.
Okay, now let's go down and do the y. Let's fill it in first.
So 3, 5, 8, 3, and then 3, 5, -2, 7.
Notice we don't even have to do the bottom. We've already figured out the determinant at the bottom.
That's right.
Because it's the same. The denominators are exactly the same.
Yes, sir.
So it saves a little bit of steps. So what's this numerator? What's the determinant of that?
-31.
9 minus 40, -31 over 31. So the y variable is -1. Now, that's an awful lot of work to do for a system of two equations. We could have solved this problem much easier by just using elimination, right?
Yes, sir.
So using Kramer's rule isn't going to be the easiest way to do it. But if you look at a system of 3 by 3 equations with 3 variables, now all of a sudden that's a lot harder to do by elimination. It might still be easier than Kramer's rule. But you start getting to 4 by 4s or 5 by 5s, now all of a sudden Kramer's rule is way easier. Because what you're doing is you're putting all of these into a calculator as matrix. So it doesn't matter if it's a 5 by 5, it's the calculator that's going to figure out what the determinant is.
Yes, sir. And the size of the matrix, is that determined by the number of variables in each equation or just the number of rows and columns?
Just rows and columns.
Okay, so a 3 by 3 would have
9
2
cells in it. I like to call these cells. Okay, and a lot of
cells.
books will call that A11, and they'll call this A1 or 2-1, and they'll call this A3-1, meaning row 1, column 1, row 2, column 1, row 3, column 1. And then you have your B, which would be row 1, column 2, B2, 2, and then B, row 3, second column. Now, where it's really important is multiplying matrices.
Yes, sir.
And here's the thing. Let's put a 3 by 2. 3 rows, 2 columns. That is called a 3 by 2.
Okay, 3 by 2.
We can multiply it by another matrix, but the other matrix has to be a 2 by anything. It can be a 2 by 2, it can be a 2 by 1, it can be a 2 by 4. What's key is the number of columns of the first matrix has to match the number of rows of the second matrix.
Yes, sir.
So if I wanted to multiply that by a 2 by 3, well, let's call these, let's see, U, V, W, X, Y, and Z. That's why it's a 2 by 3. It's got 2 rows.
Yes, sir.
Now, if I'm going to multiply them, what you do is you take this first column, you lift it up off the page, you rotate it 90 degrees, and you lay it on top of the first row. And then you multiply.
The first row of the first matrix.
The first one. Here's what I'm going to do. I'm going to multiply the U times the A, and I'm going to multiply the B times the X. And then you take the second column, and you lift it up off the page, and you rotate it 90 degrees left, and you multiply it by the second row. Then you take the third column and you do the same thing. And then your result is the sum of those 6 numbers. Oh, excuse me. No, that's wrong. The result is a 3 by 3 matrix. In other words, the result is always that times that. So I know when I multiply these things together, I'm going to have a 3 by 3. And the first thing is AU.
Yes, sir.
The second below it is B. Hold on a second. Let's see. I multiply that by that, and then I multiply CV, and then below that is EW. Just a second. First cell is that. The second cell is that. So it's AU plus BX. Second cell is CV plus DY. The third cell is EW plus FZ, and so forth and so on. In other words, the middle top cell is AV plus BY.
Oh.
And then the far upper right is going to be AW plus BZ. And I'm going to end up with one there, there, and there. So I do end up with a 3 by 3 matrix. But the most important rule is you can never multiply these things unless those two numbers are the same. And if they're the same, the resultant matrix is also always the outside two.
Yes, sir. So what you did first, you took A and B and you multiplied it by the first column. You took the first row of the first matrix and multiplied it by the first column of the second matrix.
You got it. I like to think of it visually as lifting it up off the paper, turning it to the left by 90 degrees, laying it back down on top of the A and the B, multiplying those two, adding them together. That's how I get that first of 9 cells.
Okay. Is it? And with the second row,
the second row begins by taking the second column, laying it on top of the second row. Oh, excuse me. The second row begins by that first column laying on top of the second row.
Okay.
That's how you get this cell. And then you take that same first column, lay it on top of the third row, and that's how you get this cell.
Okay.
And then you proceed with columns 2 and columns 3 in the same way. Always going downwards.
So the variables of each column in the second matrix are consistent in each of the columns in the product matrix.
Yeah. Notice that this is the number of columns, this is the number of rows. So the number of columns in the first matrix has to match the number of rows in the second matrix.
Yes, sir.
And in fact, I would not be able to multiply these. Yes, I would. Yeah, no, it would work. It would be 3 by 3, resulting in a 2 by 2. But do you have any multiplication problems?
I have one.
Okay, good, because I hate to have covered all of that if you aren't going to. I can't imagine they would cover matrices, though, without having you learn how to multiply them.
Yes, we have multiplication.
Okay, what do we got?
So,
first of all, tell me what kind of a matrix the first one is. Is it a 2 by 3? Is it a 2 by 2?
We have a 2 by 3.
Means there's 2 rows and 3 columns.
And then we have a 3 by 2.
Means there's 3 rows and 2 columns.
All right.
We'll make it a little skinnier. Okay, the first 2 by 3. And the reason I can multiply these together is the 3's match.
That's right.
What kind of output am I going to end up with?
A 2 by 2.
Hopefully, yeah. Okay, what do we got for the 2 by 3?
Okay, 4, 3, and this is going down the columns. Below. 6, 0.
I tend to think that if you're reading matrices, they go probably by the order of the letters. The letters went horizontally.
Okay.
Remember, it was A, B goes to the right, C goes below the A, D goes below the B.
Okay.
So I would guess that usually when you're talking about it, you want to go the same direction. So the second one, oops, hold on. And we got a third column on the first one.
Yes, we have one more column. And so it's 4, 3, 6, 0, 10, 8.
Okay. How about the other one?
7, 4, 3.
Hold on. Should only be 2 columns on the other one. Oh, 7, 4, 3. Okay.
All right. Do you want? Okay.
Yeah, let's be consistent and do the rows first. The only reason
Okay.
with Kramer's rule, you're kind of looking at it as columns. But
Okay.
most matrices, when they substitute letters, they always go left to right.
Yes, sir. 5, 2, 6.
All right. So it should be a 2 by 2.
Yes, sir.
What's the first step?
So we are going to multiply the first row of the first matrix times the first column of the second matrix. So that's going to be 4 times 7 plus 6 times 4 Do you want me to just do this mentally, or are we going to work out
No, let's just do one of them all the way through.
Okay. Plus 10 times 3?
Yeah, I just want to make sure you got it in the right order. So what
Yes.
is that? That is the
That's
first
going to
cell out of a total of 4 cells. We know there's only going to be 4 cells because this got to be a 2 by 2.
That's right.
Give myself a little more room. Now, what next?
Do we want to, would we go, does it matter which one we do next?
I think so. It doesn't matter as long as you're consistent. It helps to remember it. Finish doing that first column.
Okay. So now we're going to multiply the second row of the first matrix times the first column of the second matrix.
Okay.
So that is 3 times 7 plus 0 times 4, or 0, plus 8 times 3.
Okay, now what?
Now we're going to multiply the first row of the first matrix times the second column of the second matrix. So 4 times 5 plus 6 times 2 plus 10 times 6. And then the second row times the second column. 3 times 3.
What now?
3 times 5
Okay.
plus 0. 0 times 2 plus 8 times 6.
Okay. Now, I'll leave it up to you to do all those calculations, but you can see plain that you end up with a 2 by 2.
Yes, sir.
Yeah, you just have to substitute these numbers. No point in us doing that.
Yes, sir. That's right.
Okay, what else you got?
Would we be able to do one problem with 3 variables? This would be a 3 times 4 and use Kramer's rule to solve it, because we only got to do really a 2 by 3.
Yeah, your microphone, it almost sounds a little like you're too close to the speaker. It blurs things.
Yes, sir. Is that better?
Yeah, maybe sounds a little better.
Is that better?
Yeah. Okay. I can show you Kramer's rule for a 3 by 3. Will that help?
For a 3 by 3. Okay.
Yeah. To be honest with you, I cannot imagine they're going to give you anything beyond a 3 by 3. In other words, they're not going to give you 3 by 4s or 4 by 3s. I might be wrong, but I've never had a student get one yet. And if they did get it, then it was meant to be done on their calculator.
Yes, sir.
Okay, let's go through a 3 by 3.
All right.
I think the easiest way to do this is here's the 3 equations. Guess, boy, I don't know. I find these subscripts a little bit not to my liking, but I'm going to do it anyway. Row 1, column 2. Row 1, column 3. There's the first equation. With me?
Yes, sir.
We're going to have 3 equations. We're going to have an x, y, and a z. Second equation. Row 2, column 1. Row 2, column 2. Row 2, column 3. We'll put a c sub 1 and a c sub 2. And the third equation, always do row first, column second on these subscripts.
Yes, sir.
So assuming you have 3 equations and 3 variables, like this.
Yes, sir.
And first of all, the determinant of the left side is this 3 by 3, right?
Yes, sir.
In other words, when we were doing Kramer's rule before, the denominator was always made up of the determinant of the left side coefficients.
That's right.
So we're going to do the same thing with a 3 by 3. This is going to be our denominator.
All right.
This determinant. We're going to call that D.
All right.
Now, here's what x, y, and z are equal to. X is equal to the determinant of everything but x divided by the determinant
Of the left side.
of the left side. Y is going to be the determinant of everything except the y variables divided by the determinant of the left side, and z is going to be the determinant of everything except z divided by that same determinant.
And what does
Now,
that notate?
Yeah, the order matters here. First of all, this is a little difficult to memorize. I spent gobs of time trying to come up with the correct way so you can memorize what this is, and what this is, and what this is. In other words, we know that it's all of the values. This one is except for the x values, right? So
Yes,
this
sir.
d sub x has everything except a11, a21, and a31. In other words, it's going to be a determinant based on those, and those.
Yes, sir.
With me? dz is going to be based on the first row of the first column of coefficients, the second column of coefficients, and the column of constants.
Yes, sir.
Now, where it gets tricky is the order that you put them in. I think d sub x, first of all, can I erase this on the lower left?
Yes, sir.
That's just 3 by 3 matrix made up of the coefficients on the left side of the equation.
Yes, sir.
And that's in the denominator for all your answers, whatever that determinant is. And there is a requirement that that can't be 0. If that's 0, then none of this works. So let's figure out what d sub x is. First of all, I should have put that, I suppose, although the book doesn't do that. I suppose the capital D means determinant.
Yes, sir.
So what, in terms of the A's that I put up there, what do you think this would be? The X one is usually the most straightforward one.
So it's going to be, where are we going to go? The first column is going to, oh, do you,
There's 3
you
of
just,
them. There's this one, that's first column, that's second column, that's third column.
so we put them in the order in which they're found.
No, only for the X. I think I remember my logic for doing the others.
So it's different for the 2 by 2.
Well, you go towards the right. No, there is no 2 by 2. All of these matrices are all 3 by 3. Even the y. Okay. For the X, you just look at all the other coefficients and put them in order, like I'm doing.
Yes, sir.
With me?
Yes, sir.
Now, here's where it gets a little tricky. For the Y, I'm not sure my memory remembers this right, but you don't start here. You start here. And you go that column, and then that column, and then that column. Were you able to follow that?
Yes, sir.
And then for the Z, I think you keep going to the right, and you start with this as your first column, this for your second column, and this for your third column. But I'm going to have to look that. Oh, no, it's staring right in front of me here. Let me, okay. Well, I was wrong on the first one. Here, let me go back and do that. That was the only one I was certain of.
Yes.
So this 3 by 3 matrix starts with the constants as the first column.
Okay. So the X starts with the...
Starts with the constants as the first column.
Okay.
Second column is the coefficients of the Y. Third column can only be what?
The coefficients of the Z.
Okay. Now, let me make myself a little bit more room here. I don't want to erase that first one because there's a pattern here. And memorizing everything depends on memorizing the pattern. So, what's the matrix for the dy? That's the key.
Yes, sir.
What's it going to start out with?
Is it going to start with the X? The coefficients of the X?
Yeah, it does. Interesting. In other words, if you look at the X, you go right to left, right?
Yes, sir.
In other words, you know the coefficients of the X are not going to be in that first matrix. So
yes,
the question is if I go to the right, I do it like I did it the first time incorrectly. But if I go to the left, the first thing I run into when I wrap back around are C1, C2, and C3. That doesn't work either. And then the next thing I run into is the coefficients of the Y. So the y one starts out with the coefficients of the x.
Okay.
And then secondly comes the c.
Okay.
And you can figure out what the third one is.
Let's
see if we can figure out a pattern here. So the z, that starts out with the coefficients of the x. Not sure there is a pattern here. And it ends with the constants. So you can figure out what goes in the middle, right?
Yes, sir, the y.
The y, exactly, which is A1, 3, A2, 3, and an A3, 3. So I figure there is one pattern.
Yes, sir.
That starts out with the c's. That has the c's in the middle, and this has the c's on the far right side. And everything but the c's are in left to right order. Correct?
Yes, sir.
In other words,
That's
this
right.
one goes left and then the right. This one goes left and then right. And the last one goes left and then right. So as long as you get your c's in the right column, the other two just read left to right and ignore the coefficients of the variable you're talking about.
Yes, sir.
Now, there is a pattern for memorizing it. I got it down. I just didn't have it memorized before now. And it's based on the c's. The c's start in column 1, column 2, column 3. Everything else goes left to right.
So it's like whatever determinant, the determinant of whatever variable you're trying to find, that variable is going to be excluded and the constant will take its place.
Yeah. And it's just the order you got to get right. Because remember, you can't put these in any order you want. I would not be able to, in this d sub x, I would not be able to switch any of those columns.
Yes, sir.
So just remember, in the x, it's column 1 is the c's. On the y, column 2 is the c's. And on the z, column 3 is the c's. And you'll be able to figure out the other two columns always. Just make sure you go left to right on the other two.
Yes, sir.
Now, if you have one, we can do it. If you don't, I have one in my book that we could do.
All right. What size would you prefer? Would you want a 2x3 or a 3x4?
Let's try a 3x3.
A 3x. Okay.
Do the one in my book because I can do it really easy without erasing everything that I have up here.
Okay.
In other words, I'm going to erase the coefficients and replace them with numbers.
All right.
And then we'll just be able to need a smaller eraser. Maybe harder said than done. Yeah, and you can see that if you had a 7x7, wow, this is all going to go in your calculator, and it's going to be done almost instantly. Okay, so here's our equation. 2x plus y minus z, hold on. Erase all these signs too because they may be different. So it's 2x plus y minus z equals 3. Second one is minus x plus 2y plus 4z equals minus 3. And the third one is x minus 2y minus 3z equals 4. So there's our system of equations. We need 4 things. We need just the determinant of the left side. And then we need the determinant sub x, the determinant sub y, and the determinant sub z.
Yes, sir.
So what is the, boy, this is the one place where I just don't have enough room, but I'll write real small. I think once we write it out, you're going to know how to do it for sure. So what's D?
So that's going to be 2, 1, negative 1. Negative 1, 2, 4. And then 1, negative 2, negative 3.
Okay.
And then you find the determinant of that.
Right. For the moment, we know how to do the determinant.
That's right.
So let's figure out what D sub x is.
So that's going to be 3, 1, negative 1.
Oh, excuse me. Yeah. My fault. I thought you were going columns. Go ahead.
Negative 3, 2, 4. 4, negative 2, negative 3.
And what's D sub y? My terminology isn't quite right here either. In other words, in my book, when they say capital D sub x, they mean the determinant. Whereas I'm just writing out a matrix.
Yes, sir.
Doesn't really matter. I think it's all about just agreeing on a standard terminology. But
yes, sir.
So you can tell it's not a determinant. A determinant has the 2 bars. In other words, it has this means determinant. This means the matrix.
Yes, sir.
So what's the D sub y matrix?
2, 3, negative 1. Negative 1, negative 3, 4. 1, 4, negative 3.
And finally, the D sub z matrix.
2, 1, 3. Negative 1, 2, negative 3. 1, negative 2, 4.
There you have it. You can see there'd be a lot of arithmetic involved because you got to figure out what that determinant is. And in fact, you have to figure out all 4 of these determinants. But then you have your answer.
Yes, sir.
In other words, immediately you have all 3 variables.
That's right.
All right. That's a good place to end. These matrices can get pretty complicated. You may, if you start dealing with row echelon matrices and stuff like that, let me know. I'm going to have to brush up on it if that is coming in our next session. Probably won't be, but it might be. Row echelon matrix I run into every 2 or 3 years from a student taking some form of pre-calc. But this was pretty good. Handling a 3x3 is not easy, as you can see. There's a lot to memorize.
Yes, sir.
All right, Garrison, have a good evening.
All right.
I'll talk to you next Tuesday.
Yes, sir. Have a good evening.
You too. Bye-bye.
Bye.